To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to continue the lesson Home Electric Circuits or Domestic Electric Circuits. In the previous chapter, we discussed about electricity, the appliances that utilize electricity and convert electricity into other forms of energy. And thereafter, we discussed what power is. That is, when an electric appliance functions, it consumes current as well as there is a potential energy supplied across the particular device. So, there we have power, that is the energy consumed in a unit time or work done in a unit time. So, that is calculated by the equation power equals voltage into current. Thereafter, we saw the energy. So, energy was calculated as power into time, power of the appliance and the time the device is used. So, when you multiply power by time, you get energy. Or else we can calculate it using the equation energy is equal to VIT, that is potential difference, current into time. So, that is how we calculated power and energy of electric appliances. And I told you, although we supply current to a certain electric appliance, it consumes electricity, but it doesn't use up all the electricity and it doesn't convert all the electricity to the other form of energy. What is the reason? The reason is the internal resistance. All the electric appliances or most of the electric appliances have an internal resistance. Because of that, some of the electricity, some of the electric energy has to be used against the internal resistance, and that will be converted to heat. So, because of that, the electric appliances are not 100% efficient. So, you are familiar with that concept as well. So, today we will be looking at efficiency of electric appliances and conserving power. So, mainly related to the concept I just discussed, because of internal energy. There is a certain amount of electricity that is going to be used against internal resistance. So, because of that, only part of the electricity consumed by the electric appliance will be converted to its output. So, we will try to find out methods by which we can increase that efficiency. How we can increase it, or how we can select a device that is more efficient when it comes to electricity consumption. That is what we will be discussing now. So, efficiency of electric appliances and conserving power. In many instances, the same purpose can be achieved using various appliances that you all know. Now, even this lesson, you all can watch this through the laptop, you can watch it through a personal computer, or you can even watch it through your mobile phone or a tablet. So, like that, you all can use different devices for a certain purpose. Same goes for light. Now, say if you want to light up the house or your room, you can use a filament bulb, you can use a fluorescent bulb or what we call as a tube light normally. Then we can use a CFL bulb, a compact fluorescent light, or even an LED lamp. Otherwise, if you don't have any of these lights, you can even sometimes use a torch light, or you sometimes even use a light from your mobile phone. So, that is to get light. So, if you need to satisfy a certain purpose, you can choose a device. But normally, like I said, filament bulbs, fluorescent lights, CFL bulbs and LED bulbs are the most common lights used in a household. But each of them, because of the way they function, their efficiency is different. At the same time, their cost is also different. But you have to find the most efficient one for the household. That is what we are trying to understand here. So, in order to get illumination, we can use, what is illumination? Again, getting light. Illuminating means getting light. So, using different types of light bulbs. So, we can either use a filament bulb, we can use a filament bulb, we can use a fluorescent bulb, we can use a CFL bulb. CFL means compact fluorescent bulb. Compact fluorescent bulb. Then we can use LED lights. LEDs are light emitting diodes. Now you are familiar with filament bulbs, normal tungsten bulbs, where you have a filament inside the bulb. So we have discussed this before. You supply electricity to the bulb. Then what happens? Due to that electricity, the filament gets heated up. So electric energy is initially converted to heat energy. Then what happens? Because of that heat, the filament starts to glow and that emits light. So that is how filament bulbs illuminate a place. Then if you take the fluorescent bulbs, that also you are familiar. Now when we supply electricity, initially there is UV radiation produced. So electricity is initially converted to ultraviolet rays, that is a form of electromagnetic energy. And thereafter there is light energy produced. So there is an energy conversion taking place before you get the light energy. So in both filament and fluorescent that happens. Then CFL is also a type of fluorescent bulb, but it's compact. Normal fluorescent bulbs are referred to those tube lights, the tube bulbs, which are long. But CFL, they are compact. They need a smaller space. You have seen them, the coil-like structure. We'll be looking at the diagrams after this. So that's a CFL bulb. Then we have the LEDs. We have not discussed diodes and transistors yet. We'll be discussing them with electronics, but you're familiar with diodes, light emitting diodes, diodes that can give out light. So there are bulbs that are made using light emitting diodes. So those are the LED lights. So different types of lights or bulbs can be used for the purpose of illuminating a space, converting electric energy to light energy. Now we will need to understand which one is more efficient. That is the important thing. So with that, students, I am going to move on to the next slide and continue with the discussion. So here, choosing a more efficient appliance helps us to save energy. So the main important concept is to save energy. Now why do we need to save energy? To save energy. Two different purposes. One thing, it's good for us because anyway you need to pay for electricity consumption. So if you can save energy, if you don't waste electricity, you can save money. That is one thing. Then it is good for the environment as well. When you conserve energy or when you save energy, it is good for the environment and the natural resources. So for both reasons, it is advisable always to choose more efficient appliances so that you can save energy. To do that, you should know about the different types of appliances that are available for a certain purpose. So a few different types of bulbs giving the same illumination. So that's important. You get the same amount of light, same illumination. Now if you select different bulbs of the same type with different power. Let's say if we take a filament bulb with different power, say 10 watt power and 60 watt power. Now obviously 60 watt power bulb would give more illumination. There you can't really compare. But here what we are doing is we are considering bulbs that give the same illumination. Their output and lifetimes are given in the table. So when we say power output, the amount of electricity they consume to give out that particular illumination, and also the lifetime, how long you can use that particular bulb. That's also very important. If it cannot be an efficient bulb, if you can use it only for a short period of time, the longer you can use, it becomes more efficient. The less power consumption for the same illumination, it would be more efficient. So that is why we need to consider all these. Same illumination, but we need to consider the power output and the lifetime. So we'll look at this table, the table given in your textbook. Power and lifetimes of various types of bulbs. So here, like I said, all the different types of light sources are given to you. The filament bulbs, fluorescent tubes, CFL bulbs, that is compact fluorescent lights, and LED, light emitting diode lights. The 4 different types. Now look at the power. For the same illumination, now filament bulb takes up 60 watts of power. Then fluorescent tubes, they consume 22 watts of power. Whereas the CFL bulb, that's the compact fluorescent lights, they consume 11 to 13 watts. And the LED lights, 6 to 8 watts. Now, if you take a filament bulb and an LED light, you can see 60 watts, 6 to 8 watts. So, almost 10 times less than the filament bulb. But it gives the same amount of light, same illumination. So, if you only consider the power, what do you think is more efficient? As you go down, the power consumption is less. So, obviously, the electric appliance that consumes less power to give the same illumination is more efficient. So, compared to filament bulb, fluorescent tubes are more better. That's the tube lights. Then CFL bulbs are even better. As you see, it decreases. The power consumption decreases. And the LEDs are the most efficient. The least efficient bulb is filament bulb. Most efficient one is LED. That is only considering the power. Now we will look at the lifetime as well. Now here you can see lifetime, 1200 hours. So that is the maximum time you can use this particular filament bulb, 1200 hours. So you can either continuously light it for 1200 hours, but normally we switch it on, then during the night time or when it is dark, we switch on the light, then we switch it off. Night time when you're sleeping, when you're not using the light, you don't need it. And daytime also, when there's enough sunlight falling into the place, then also you may not need the light. So we switch off and on the light, but maximum time period you can use is 1200 hours. So this is going to be not going to be continuous, but totally you can use it for 1200 hours. Then if you look at the fluorescent lights, that's for 3000 hours. So more than filament bulbs. Then CFL, it's 8000 hours. So about a very longer lifetime compared to the first two types. And if you take the LED bulbs, 50,000 hours. Very much high compared to the first three types. Filament, fluorescent and CFL. Compared to all three, the lifetime of LED bulbs is very, very high. So what can you understand from that? LED bulbs are energy efficient. They consume very less power and they have a very long lifetime. So obviously they are more efficient. At the same time, there is something else that you need to consider. Now, usually filament bulbs are cheaper in price compared to LED bulbs. But if you consider the long-term usage, if you calculate it that way, if you consider the power consumption and the lifetime, obviously the LED bulbs are more efficient. So that is what you need to consider. Now here, of course, this one, that is the power and the lifetime. Here students, you all have to remember, you don't have to memorize the values, but you need to have an understanding as to which is more efficient. So if we take the LED bulbs, now just if you take a bulb and look at the price, filament bulbs are cheaper compared to LED lights. But if you consider their power consumption and lifetime, it is more efficient. For the price you pay, the longer it lasts and the less power consumption. So the most efficient one is the LED bulb. So here, least efficient is going to be filament bulbs. But most efficient is going to be LED lights. So that is how you compare the different electrical appliances. Is that okay, students? So from now on, when you all are going to purchase a light bulb, you need to consider all these factors. You have to look at the power output, the lifetime of the bulb, the lights, and also you consider that along with the price. Then you can decide carefully which is more efficient. So don't just look at the price only. Look at the other information. So basically energy efficiency means they have more lifetime and they consume less electricity for the same illumination. That is how LED lights are more energy efficient. I'm sure you all can understand that. So with that students, I'll move on to the next slide. So here, first if you look at the picture, you can see the different types of lights. The first one is a filament bulb that you all are familiar with. This is a filament bulb. Filament bulb. Even this you would have seen neon lights. We have discussed this when we discussed current electricity in the previous grade. When we did an activity, we used a neon bulb. A neon light or neon bulb. Then this is a CFL bulb or CFL light, and this is an LED, light emitting diode. LED bulb. So 4 different types are shown to you, but already we have discussed which is more efficient. Now the LED has a very long lifetime, about 50,000 hours, and it consumes only 6 to 8 watts of electric power. So that is more efficient. It is advantageous to use LED bulbs as light sources. However, the use of LED bulbs in Sri Lanka is limited due to their high initial cost. So you have to understand that what I meant when I said when you buy the bulb, the price of a filament bulb is less compared to the price of an LED bulb. So that is the initial cost. So this is something you all have to understand. It's actually advantageous to use LED bulbs, but they are high initial cost. But that high initial cost, when you compare with the amount of electricity that you are going to consume in your household and you need to pay for the electricity, it will be more efficient. So that is why people haven't still got used to using the LED bulbs, because of their high initial cost. So you have to remember that. It is advantageous to use LED bulbs because of the efficiency, but they have a high initial cost. I'm sure you all can understand that. So with that, students, we'll move on to the next slide. So here again, earlier we discussed lights. Now the next type of electric appliance is the cooker. Cookers differ from one to another due to varying amounts of heat wastage. Now, you all use cookers for cooking purposes. We have the cooking vessel on the cooker and we cook. So, while the process is taking place, while we are cooking, there is a certain amount of heat energy being wasted from the cooker. So, if heat is going to be wasted, obviously electricity or the fuel that you are using will be wasted. So, here we are going to look at only the cookers that use electricity, electric cookers only. We are not going to discuss about other types of cookers. So, we'll look at some of these examples. Now, all cookers that use heating coils are the lowest in efficiency. You all are familiar with heating coils. We have seen this. Now, when we previously discussed devices, the different conductors, different metals or substances that have very high resistance usually tend to produce high amount of heat. So, those are used as heating coils. We discussed one example. You are familiar with nichrome, an alloy of nickel and chromium. So, that also has high resistance. So, it's used as the heating coil. There when we use irons, electric irons, nichrome is the heating coil. The same goes for normal ovens as well. Now, ovens also have that heating coil. So, mostly in the old cookers, old ovens, old cookers, they use heating coils. Now, from this, a lot of heat energy will be wasted. So, that means lot of electricity is also going to be wasted. So, that is the lowest in efficiency. It is the lowest in efficiency. So, nowadays we don't use these types of cookers that much. But we have different types of cookers and different methods of doing a certain function. Say for example, if you want to boil water, you can use an electric kettle, you can use an immersion heater, or you can use an electric cooker. On that you can place a normal kettle or a vessel and you can boil water. So, there are different methods of doing the same activity. So, we will see which is more efficient. Now, immersion heater is highly efficient for heating water. All the heat generated in the heater is transferred to water. This is something that we have already discussed. You are familiar with the concept. Now, if you look at the pictures, here you can see this is a hot plate. Now, this is the part that becomes hot, and under that also there is a heating element. Here, this is the immersion heat. Now, how do we use these immersion heaters? Now, you are familiar with heat and heat transfer. Now, if this is a vessel containing water. Now, immersion heaters are inserted into water. How does heat transfer in water? By the process of convection. So, here this is water. You are familiar with the concept of convection. The convection current, and that is the heater. This is connected to electricity. So, here this is a container vessel containing water, and that's the immersion heater. You can see that. So, here immersion heater. And like I said, the convection process. So, what happens during convection? You supply heat. Now, here water. Now, from this coil only heat is given out. So, that is heat given out. Then what happens? In water, the particles that become hot, they tend to rise up. And the cool particles move down. So the heating occurs from bottom, the hot water goes up, cool water comes down. That's how the convection current occurs, and that is the process of conducting heat or transferring heat in liquids. So because of that, now if you immerse the immersion heater right to the bottom, then what happens? Easily all the heat is given to water. There is no way heat is lost from the immersion heater. Why? Because the immersion heater is completely inside water. And from there, heat is given throughout the water. So it becomes hot more quickly and efficiently. So therefore, using an immersion heater is more effective than using a normal cooker. The same goes for electric kettles also. But electric kettles, the coil is at the bottom, something similar to this hot plate. Now here you can see this is a hot plate. The heating element is at the bottom. Same goes for electric kettles. The heating element is at the bottom. So from there heat is given to water. Then from there the water gets heated up. So but depending on the structure of the appliance, if you can prevent loss of heat, then you can prevent loss of energy or make the appliance more electric energy efficient. So like we discussed, if you look at different ways that could be used to heat water, now immersion heaters are more useful. Immersion heater is highly efficient for heating water. So here what happens, like I said, all the heat generated in the heater is transferred to water. Why? Because the immersion heater is immersed in water. It's inside water. So all the heat can only be lost to the environment, that is water. So all the heat will be absorbed by water. There's no heat loss to the external environment. Around the immersion heater, it's water. So it's very efficient. Then there are heaters which contains hot plates such as rice cookers is more efficient because heat loss is less from them. So again, different types of heaters. Heaters which contain hot plates such as rice cookers. So here this is a normal hot plate on which you can keep a vessel and cook. Now rice cookers, you have the cooking jar, you have the outer cover, inside you keep the cooking vessel, but below that is the hot plate with the heating element. So there are also the cooking vessel. Now even on this, if you place the cooking vessel here, now that the bottom of the cooking vessel is directly in contact with the hot plate. So all the heat that is produced will be given to the bottom of this vessel, and from there it will be transferred to the substance that is present inside. So what do we need to do? We have to make sure that we place a container, a vessel that actually fits into this size. If it's small, then of course there is going to be heat loss. But in a rice cooker, where it is all made up, there the heating element is below, the hot plate is below, and there is the vessel that exactly fits the size of the hot plate. So there is less energy wastage, or it is more energy efficient. So heat loss is less from them. That is what you have to remember. So the same thing goes for electric kettles also. Electric kettle, again it is compact, it's made like in such a way that you have the hot plate, on top of that you place the kettle. So there are also less energy loss from that. So that is how you choose the different appliances. Is that clear to you all students? So for heating water, immersion heater is very efficient because you immerse the heater, all the heat is supplied to water and water gets heated up by the process of convection. So therefore, there is no energy loss to the environment from the immersion heater. So it's usually quick and efficient to boil water using the immersion heaters. Same goes for hot plates. The energy loss is less from hot plates. For example, devices like rice cookers, electric kettles, another example, electric kettle, electric kettle. That is also a device, an appliance that uses a hot plate. So these are all very efficient. Is that clear to you all? So with that, students, I'll move on to the next slide. Here we look at another two types of cookers. One is the microwave oven, then the induction cookers. Now we will discuss them one by one. So here this is a microwave oven. You're familiar with that concept also. Now we have discussed microwaves. They are electromagnetic waves. So what happens is inside the microwave oven, the microwaves are generated and they cook using the components of the food. Normally the lipids or fats and water. Water molecules in food is used up to produce heat, to generate heat. So that way microwaves are very efficient form of cooking. But the problem is you can't cook all types of food in a microwave oven. And also you can't use all types of vessels. So the usage is limited. But when it comes to electricity efficiency, that is more efficient. At the same time, you need to consider the harmful factors related to microwaves as well. So you all know when a microwave is functioning, you should not stand closer to the microwave. You should be away from it as much as possible. Although the modern ones, they have all the protective measures, but still it is advisable to stay away from that. But when it comes to electricity efficiency, microwaves are efficient. At the same time, there is a limitation because you cannot cook all types of food using microwaves. The limitation is there. So microwave ovens are very efficient since they produce heat inside the food items. That's very important. Microwave ovens, they produce heat inside the food items. Like I told you all, they use up the fats, water content, all those to generate heat. But they cannot be used to cook all types of food. So that is something you need to consider. Microwave oven. Then the other type is induction cookers. Now there are electrons, there is electromagnetic induction. We will be discussing that later. Using that, they generate heat. That is an induction cooker. Only thing is, for an induction cooker also, you can use only certain types of vessels. Anything related to iron, steel, that can be related to electromagnetic induction. The magnetism property has to be there. So only those vessels can be used in this induction cooker. But that is also very, very efficient. The electricity consumption is very less. Heat loss is also less. So because of that, it is very, very efficient. But again, the vessels that you can use are limited. Only vessels made up of either iron or steel can be used. Any type of steel. Induction cookers with high efficiencies are now available in the market. Variable magnetic field. So like I said, induction cookers, they use magnetic field. Variable magnetic field emitted by the cooker generates heat only at the bottom of the cooking utensil. That is very important. Generates heat only at the bottom of the cooking utensil. So hot plate, that is the difference. Now hot plate, the full heating element generates heat. Whether you have a small vessel or large vessel, it doesn't matter. But here, this generates heat only at the bottom of the cooking utensil. So, you have a small utensil, heat is produced there. If you have a larger one, heat is produced there. But at the same time, they give a limitation, they specify a certain size. The vessel should not be too small or it shouldn't be too big. Then the efficiency reduces. So, if you use the correct vessel, and you have to remember it has to be either iron or steel vessel. That is something you have to remember because of this magnetic field. Only with these types of vessels, the magnetic field will be emitted by the cooker that will generate heat. Is that clear to you all? So, different types of electric appliances that can be used for cooking. So, there is the immersion heater, normal hot plates for boiling water. Then you have the hot plate rice cooker, microwave ovens, induction cookers for different cooking purposes. Now, although we say rice cooker, normally it is used to cook rice. But at the same time, you can make curries, you can make other types of dishes also using the rice cooker. But then again, there is a limitation. You cannot cook all types of food. Same as microwave oven. Microwave oven is also very useful, very efficient, but you cannot cook all types of food. But if you take an induction cooker, you can cook any type of food, but the problem is you cannot use all types of vessels. There is a limitation there. So again students, now you have discussed or we have discussed so many different electric appliances used for cooking purposes. But you need to choose them depending on your requirement. What type of cooking you are going to do, how efficient you are looking at, because these are efficient in different ways. At the same time, they do have certain limitations. So you have to consider all that. I am sure you all can understand that. So with that, we'll move on to the next slide. This is an extra knowledge slide for extra knowledge. The power consumption of television sets that use LCD, liquid crystal display. LCD means liquid crystal display. Liquid crystal display. So, the power consumption of television sets that use LCD screens is lower than that of the old televisions that use cathode ray tubes. So, two things that you need to consider. One thing LCD screen, the other one cathode ray tube. Now, you are familiar with this cathode ray tube also. Now, in matter, they are made up of atoms. In atoms, there are electrons. The rays, electron rays are known as cathode rays. So, there is a tube, a vacuum tube. When you apply a potential, there are cathode rays generated. So, the old TVs, old televisions, they had a screen that had a cathode ray tube inside. So, based on that only, the picture is generated. That is why sometimes when the screen cracks or gets damaged, you see a greenish color light. That's because of that cathode ray tube. But that is more high energy consuming televisions. But the modern ones which use a liquid crystal display, the LCD display, that consumes less energy. So, it's more efficient. LCD television sets that use LED lights to illuminate the screen have a very low power consumption and are known as LED televisions in the market. LED televisions. So, we already discussed LEDs. Now, LEDs, light emitting diodes. So, here the picture illumination is carried out by using light emitting diodes. As you already remember when we discussed the light bulbs, LEDs have a very low power consumption. So, because of that, They are very, very efficient. So LED screens or the LCD screen, LCD TVs which use LED to illuminate the screen, they are very, very efficient compared to the old TVs that used cathode ray tubes. Is that clear to you all, students? And also you are familiar with the size of the TVs also. The cathode ray tubes, normally the TV was very large. Now the size of the TV, it has become more and more thinner. So that is also more useful considering the reduced space available in most of the households. So one thing, energy efficiency, electric energy efficiency, and also the space efficiency. So the LCD televisions are more efficient. Is that clear to you all? So with that, students, we'll move on to the next slide. So then another type of electric appliance used to provide wind or give rise to cooling effect. So one thing is the table fan, the other one is the ceiling fan. You are also familiar with pedestal fans. Again, another type of fan. So all these, when you all know, when a fan works, it rotates the air. But the way it does that, now if you take a ceiling fan, you all know why we call it the ceiling fan. It is connected to the ceiling. Normally under the roof there is the ceiling, or now with all the many storied buildings, you have the flat roof slab where the fan is connected. So there, when the fan rotates, what happens is it pushes the cool air down. It rotates the air and it has to push the air downwards. So because of that, when it works, now it has to push the air downwards like that. So it has to push it down. So because of that, it needs to consume more electricity. But if you take the table fan or the pedestal fan, now again depending on the size also it varies. But if you take the pedestal fan pushes the air. When it rotates, it pushes the air from inside to outside. So because of that, the electricity consumed by the table fan is lesser. And also you are familiar with the blades. Now the table fan, it has very lighter plastic blades. You do get ceiling fans with light plastic blades which are more efficient compared to the old fans which had very heavy blades and all that. But still, the way they function, table fans consume less electricity compared to ceiling fans. So if you are considering electricity efficiency, then the most suitable one is the table fan. Similarly, it is more efficient to use table fans to cool houses than ceiling fan. So this is what I explained. It is more efficient to use table fans to cool houses than ceiling fans. Using the most efficient device suitable for a particular purpose whenever possible would help to minimize the future energy crisis. So like I told you all, two main purposes can be satisfied. One thing, it is efficient for us, that is the household user when it comes to electricity consumption, and also the future energy crisis to reduce that. If you consume less electricity, more electricity can be conserved, and that will help to prevent or minimize energy crisis in the future. So that's very important. So you have to consider all the reasons. Now sometimes, when it comes to cost, people tend to go for cost-effective electric appliances. That is the devices that are cheaper in price, but they do not consider the long-term expenses or the efficiency. So you have to consider all that. And at home, if you have various devices, now some of the households, you will have a ceiling fan, you will have a table fan. So depending on when you want it, if it's going to be only you who is in the room, and if you are seated in your table trying to study or do some work, then you can easily use the table fan, which is more efficient. But then if there are about 10 people seated in the living room and you all have the ceiling fan and the table fan, maybe you will have to go for the ceiling fan, so that air is blown throughout the living room and it becomes more cooler. So depending on the situation, if you have more than one appliances at home, try to use them efficiently. So that is one way of making use of electric energy efficiently. And at the same time, when building a house, when having all these electric appliances, when buying them, consider all the different factors so that you can contribute to minimize the future energy crisis. I am sure you all can understand that, students. So with that, we'll move on to the next slide. Now here, if 40% of the energy supplied to a certain electric appliance is lost as heat, then only 60% of the energy would be used for the expected purpose. So for example, let's say you have a lighting bulb. You supply 100 watts of energy to that. Only 60 watts of energy is converted to light. The rest of the 40 watts, 40%, will be used against internal resistance. So the efficiency of the bulb is only 60%. So there you are losing. There is a loss of 40% of electricity. So that is not very efficient. Now this means that the efficiency of the electric appliance is 60%. So if you have appliances in that manner, you have to come up with ways where you can increase the efficiency. Even our daily practices can lead to efficiency in using electricity. Some are given below. So we should try to minimize the loss of electric energy as heat and get the maximum out of the electric energy supplied for a particular purpose. So we should try to reduce the loss of electric energy as heat. So you know why it is lost as heat, because of the internal resistance. So by doing it in certain ways, by following certain procedures, we can try to reduce that. Some are given here. Now first one. Now you can look at the picture here. Now sometimes, because we are in a hurry to go somewhere, we have a very fast lifestyle. What happens is, in a household, if there are 4 family members, all 4 people iron their clothes at different times. And sometimes what you do is, you yourself, maybe you iron a cloth in the night, the previous day, then in the morning you realize you have missed something, again you iron another piece of cloth or some kind of a dress in the morning also. So you use the iron for one person, for one particular purpose, but twice. There, each time the iron gets heated up, there is more electric energy consumed. But instead, if you can iron both the clothes in the night, and if there are, say, 4 family members, 4 people using the iron at different times, without doing that, if all 4 can iron together, maybe you can take turns, or you can come up with some sort of method to iron those clothes all together at once. Then you save a lot of electricity. At the same time, so if you can iron all the clothes that is needed for the whole week in the beginning of the week, or you select a particular day and you iron all the clothes on that day itself. So there again, you minimize the loss of energy, because there, when you use the iron for a longer time, the amount of electricity needed to reheat the iron becomes lesser and lesser. Because you are using it for a long time, the iron is usually hot throughout a particular period of time. So it's more efficient. So ironing clothes all together. Ironing all clothes required for a week in one occasion is more efficient because it saves electricity used in the initial heating of the iron. That's important. So here, because it saves electricity used in the initial heating of iron. If you iron each cloth separately, every time the iron has to become hot. So that is the initial heating of the iron. For that, there is more electricity consumed. But when you iron them together, there's only one initial heating, and thereafter you all know the light goes off when there is enough heat and it comes on, you know the electricity is being consumed when the heat decreases. So there you save a lot of electricity. The same goes for lighting bulbs. Now again in the picture you can see a CFL bulb and an LED bulb. So out of all the 4 types, you all know LEDs are the most efficient. CFL is also efficient compared to the other 2, filament bulbs and fluorescent bulbs. So all the unwanted lights of the home should be switched off. So that is something you have to do, not only in your home, even in school, in your classroom. When all of you all are leaving the classroom for some purpose, you have to make sure that all the lights, even the fans, everything has to be turned off. So all the unwanted lights of the home should be switched off. Also, you have to use more efficient bulbs such as CFL and LED bulbs. So again, we have discussed about the cost and the efficiency. Initial cost is high, but with time, long term, it is more electricity efficient. So you have to consider all these factors when you are trying to use electricity more efficiently. I am sure you all can understand that, students. So with that, students, I'll be moving on to the next slide. So there is an assignment for you all to do. Prepare a list of electric devices used in households and indicate their power usage against them. You may use the specification labels pasted on the device or the instruction sheet provided with the device to do this. Get assistance from an adult when this is not possible. So normally you all get that. If you have some kind of any electric appliance, if you turn it at the bottom of the appliance, usually there is a label pasted. Or in the power pack, the power cord, with that a label will be attached. Otherwise, you are provided with an instruction manual. In that also they give you the specification. Usually they give you the voltage that is needed, then the current consumption, usually power, all these are given to you. Voltage in volts, current in amperes, power in watts, all that is specified there. And also they say whether you need to use alternate current or direct current. We'll be discussing that later. But you all are familiar with that. You would have seen AC, DC, those specifications are there. So you can look at all the devices. Now normally in a household, there will be a television, a radio, a laptop or a computer, a refrigerator, maybe a rice cooker, electric kettles, electric irons, even electric cookers. So like that you will have immersion heaters, whatever most of the devices that we discussed. Even washing machines like that, there are so many different electric appliances. Electric motors, we have discussed all these appliances before. So even all the different types of light bulbs, fluorescent bulb, LED, CFL, you can look at all those. Now the bulbs, they normally don't have a sticker pasted or a tag there, but you are given a small leaflet, a booklet. So there you get all the specifications. So what they want you to do is, they want you to prepare a list of electric devices that are used in the household. Not only your household, if you know that there is a different type of device in your friend's house or a relative's house, you can look at that device, that information, just to get the information so that you have a very good idea about different electrical appliances. So you need to make a list. You can write down the voltage, current consumption, power consumption. So then you can compare the efficiency. So that is what you are expected to do here. If you can't do it on your own, you can get the help of an adult. Maybe your teacher or your parents or an adult in your household to help you with the values and the information. So make that list so that you will know which is more efficient, which appliance is more efficient for your particular purpose. So if you know that, in future you can use electricity and conserve electricity more efficiently. With that, students, I am going to end this chapter, and in the next chapter we will discuss household electric circuits or home electric circuits.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.